So as far as quadratic equalities go, the first thing I want to make sure we understand is interval notation. So found out from first period that you already know about interval notation, but just to be sure, I'm going to review. So if I start and if I give you something and I say like x is greater than or equal to 2, right? And I say, well, what does that picture look like? Well, it's x is greater than or equal to 2. This means this is representing on a number line, here's 2, I'm going to fill the circle in, and since x is bigger, it represents everything's to the right. Everybody okay with that part? Same thing if, and to sort of contrast that, if I have x is just greater than 2, that's going to represent, we still have a number line, but this is 2, I have an open circle, and I'm still shading everything to the right. Are we okay? Back to whatever elementary school or pre-algebra, wherever this is, if I have the greater than or equal to means this is filled in. If it's not equal to, it's just an open circle and we're shading. It's still talking about like a range of numbers on the number line. The other version of this is, well, what if I talk about x is in between, I'll say -1 and 3. And so this is telling us to shade in between -1 and 3. These get filled in circles, and we're going to shade in between. And on this one, with the -1 and 3, and this is -1, this is 3. These give you open circles, and we're here. Everybody, this is review, right? Okay, a whole lot of review. Okay, now what interval notation does is describes this picture, right? So for this particular one, if I want to describe the shading between -1 and 3 with interval notation, I'm going to start shading at -1, I stop at 3, and I use parentheses. All right? Because if you think about this, when the interval notation, it says shade from -1 to 3, right? I shaded from -1 to 3. This is describing that picture. Well, what's the difference if it's equal to, right? There's got to be some difference. And the difference is I can start at -1 to 3, but when you include, then you have a little square bracket, and then, so the difference between, open circles and closed circles is you get parentheses and brackets. All right? Okay, so then how do you describe something like this? We're going to start at, how do I describe what I'm shading? Well, I'm starting at 2, and I go all the way to the right. Well, all the way to the right is infinity. And since I don't include, I get to use a parentheses, and I didn't include the infinity, I use a parentheses there. And then how do you describe it in this case? And this is the only one that's a little, that requires a little more explanation. I'm starting at 2, I still go to infinity. This is included because I get the little bracket. But infinity is an idea, you never include infinity, so anytime you use infinity, it always uses a parentheses. Okay, so here's my little brief review of interval notation. You already knew interval notation? And the idea with interval notation is it's describing the picture that you have on the number line. Okay, so what are we doing? Well, we're starting with, let's say I give you x minus 2 times x plus 3, and this I'm interested in less than or equal to 0. So I want to solve this quadratic inequality, right? And so how do you do it? Well, before we talk about solving this, I want to refresh our memory on just solving a quadratic equation, where if I had just given you x minus 2 times x plus 3 equals 0, because this is easy. Because when I look at this, okay, this is an easy thing to solve. What makes it 0? Well, what makes it 0 is a 2. What makes this 0 is a -3. And so my answers are 2 and -3. Done, right? But when you're solving an inequality, you don't get one answer. You get a range of answers, right? And how you describe a range of answers, the way we're going to describe that range of answers is on a number line. And so how do we do it? Well, the way we solve this is we actually do pretty much what we did here. Since we're interested in where this thing is around 0, well, I need to know what makes this equal 0. And what makes this equal 0 is the 2 and the negative 3, right? Same thing as was over here. And since I'm interested in a range of numbers, well, I want to draw my number line. And on my number line, I'm going to identify, now some of you get, it's probably based on previous teachers where whenever you draw a number line, they require you to draw all the little tick marks. And to be honest, all the tick marks aren't terribly important. Really, there's only two numbers that are really important. The two x values that are important are the negative 3 and the 2. Because those are the values that give me 0. Right? Okay. Now, what these values do is they actually take my number line and they divide it into 3 parts. And your job, or our job, is to determine which parts work. Right? First, since I'm going to divide the number line, they get circles. It's less than or equal to, which means these circles will be filled in. So I'll go ahead and fill them in. Actually, I have to use a different color. So this is good filled in. Right? And we have to determine, okay, I've got the 3 parts, and I say, well, I have to check each part to see if it works. Yes?
Sorry, so why did you start with circles? Just like.
Well, whenever we shade on the number line, we the numbers that we include, we put circles.
Okay.
Does that make sense?
Yes.
Okay.
I have a really dumb question.
Mm-hmm.
Just I'm having a brain fart, but that. So why is it positive instead of just -2 and positive?
You want to know what value of x makes this 0. So when you have this, imagine you take this thing and set it equal to 0, like this thing over here. If you set it equal to 0,
then x is equal to 2.
Yeah.
Oh, okay.
Because what you're trying to do to get it equal to 0, one of these things have to equal 0.
Okay.
All right. So now, I've got to figure out which part works. How do you do that? Well, here's the argument. This section either works or it doesn't. Okay? And so what we could do is we could check any number in this interval, and if that number works, that means the whole interval works, or if that number doesn't work, that means the whole interval doesn't work. And so you get to pick any number in this interval. So, what would you pick?
0.
Well, 0 would be this interval.
Oh,
Wait,
that
why?
interval.
Why?
-5.
So you can pick -5. You can pick any number in this interval, right? Remember, we're on a number line, right? 0's over here, right? So any number, you can pick -5. And believe it or not, I'm going to pick a number that's going to make my life incredibly easy, right? 5 works. There's nothing wrong with that, all right? But I'm going to do -100, okay? And the reason I'm going to pick an extreme value is I don't care what the actual number is. See, when you're trying to determine if something's greater or less than 0, well, something greater than 0 is positive, right? And something less than 0 is negative. And so what's actually important isn't the value, but am I going to get a positive or negative number? See, here's how it works. Let's say I pick -100, right? -100 minus 2. Is that going to be a positive or a negative number?
Negative.
Pretty easy to figure that part out, isn't it? So this is going to be a negative number. -100 plus 3, is that going to be positive or negative?
Negative.
Negative. Negative times negative is?
Positive.
Positive. Is a positive number less than 0?
No.
No. Okay, this doesn't work. Right? Now let's try a number in here. What would be a very easy number to check?
1.
0, right? Right? Anytime you can pick 0, you want to pick 0. Okay? And so now when I plug in 0, let's see. 0 minus 2, I'm pretty sure that's negative. 0 plus 3, I'm pretty sure that's positive, right? Negative times positive is negative. Is a negative number less than 0?
Yes.
Yeah, okay, so this one works. And then over here, I'm going to pick a value. Guess what I'm going to pick over here? Positive 100, right? Anytime you can pick an extreme value.
Does it make a difference if it's less than or equal to, and then if it's without the less than or equal to?
So the difference between the equal to means the dots are filled in.
Oh, okay. So
And if it doesn't have the equal to sign, then you have an open
so
circle.
does it have a difference between whether or not it works or not?
No.
Okay.
No. As far as you're still the reason we like 0 is it makes it easy to determine if something whenever 0 is kind of what we're comparing, then we're just looking at something positive or negative, and that makes our life a lot easier. Okay? So if I go here, like I pick 100, well, 100 minus 2, that's clearly positive. 100 plus 3, that's clearly positive. Positive is positive. Is a positive number less than 0? No, it doesn't work. And so what we've just done is we've identified that from here to here works. Right?
Yeah.
And since from here to here works, now to write this in integral notation says I'm going to start at -3, I'm going to stop at 2. I include the -3, so I have this. I include the 2, I have this, and that's my answer. You see how that worked? Right? So just kind of recap. In solving an inequality, it's very important to understand that in inequality you're getting a range of numbers, right? To solve an equation, you're just getting like a finite number. I have 2 answers. But in solving an inequality, I get a range of answers. And anytime you get a range of answers, you want to find, I call them the boundary points. It's basically what makes it equal 0. Those are your boundary points. Those boundary points break up your number line, in this case to 3 parts. And now you have to check to see which parts work. All right, in this case, the middle one worked. I shaded the middle part, and so this is my answer. All right, your turn. And so what if I give you, let's do x.
I forgot what determines whether or not if it's brackets or parentheses.
The equal to or not. If it's filled in, if it's filled in, you get a bracket. If it's not filled in, you get a parentheses.
Okay, and then infinity is always just a parentheses.
And then you always use an infinity with parentheses. Right? So what if I gave you x minus 5, x plus 4? In this case, I want it greater than 0. I'll pause. All right. It's running out of time in the first period, so I want to make sure I get through. Just so you know, there's like 4 types of problems I need to make sure we know how to do, because that's what your homework is. Yes?
So if it equals 0, like if when you're like plugging in, if it like one of them equals 0, like do you like does it not work? If it's like a greater than.
Well, no. So how you approach this problem is actually you start it the exact same way. So I want to know like my boundary points. What makes this 0? So in this case, what makes this 0 is a 5. And what makes this 0 is a -4.
Yeah. So if
Okay.
I'm plugging in like -100.
Okay, well, let's look at our number line, right? So in this case, the only x values I care about are -4 and 5, right? And in this case, I'm going to put open circles because it doesn't have the little equal to sign. And so now I've got my number line. I've divided it into 3 parts, and so now I have to check which parts work. So -100, right? So -100 minus 5, well, that's negative. -100 plus 4, that's clearly negative. -100 is positive. Is a positive greater than 0? Yep, right?
Oh, yeah.
Positive number is
Yeah.
greater than 0, so this works. Next, I'm going to check a value in here. What's a reasonable value to check in here? 0, right? Anytime you can check 0, you want to check 0. And then I go through and 0 minus 5, well, that's negative, right? 0 plus 4, that's positive. Negative times positive is negative. Is negative bigger than 0? No, that doesn't work. Then I'm going to pick a value over here. Guess what I pick? 100. 100 minus 5, clearly positive. 100, clearly positive. Everybody's positive. Is that bigger than 0? Yep. And so in this case, I have 2 areas that work, don't I? I've got this area, and so I'm going to shade here and here. Now I'm going to use interval notation to describe this. And to describe this interval, you always describe left to right. So the furthest left is -infinity. It goes to -4. And these are open parentheses because that's an open circle, right? And infinity always gets an open parentheses. To describe this, I'm going to start at 5. It goes all the way to infinity. And again, I get those open parentheses on each one. And as much as I hate it, anytime you have multiple intervals, you got to put that little U thing. I don't know if you've had to do that before.
The union.
Yeah, the union. Because it's representing both of those.
I can't see what the second answer is.
You said what?
I can't see what the second answer is. Can you tell me what it is?
The second,
Oh, the 5 infinity.
the 5 to infinity? Oh. Sorry, my tower of books is in the way.
Yeah.
Yeah, I wish I had a less obtrusive
So
tripod.
that's the answer.
You could
Yeah.
put it on your computer.
Then it would be too low. I need to, and honestly, I'd rather have this camera up higher than this. So. All right, so that kind of makes sense? And you're thinking, well, why, you might be thinking, well, why are you doing all these extremes? Well, these are really basic cases of, let's think about what happens if I'd given you, let's do 5x minus 3 and 4x plus 7. And I want this, we'll do greater than or equal to 0. Right? So now the numbers aren't as pretty, right? So how do you do it? Well, same way. Treat this like an equal sign. We want to find our boundary points. And so you ask yourself, what makes this 0? Well, what makes this 0 is 3 over 5. What makes this 0 is a negative 7 over 4. Right? And now when I draw my number line, there's lots of numbers. I really only care about the 3 over 5 and the negative 7 over 4. And even though I'm not quite sure where to plot them, right? I just know this better be on the positive side and this better be on the negative side, right? That's really all that's important. And now, well, I got to put circles. Right? Do I fill them in or leave them hollow? Fill them in, because that's filled in. And now we kind of have the same situation. I've got to check my intervals. So to check my intervals, I've got to pick a value over here. Well, what would be a reasonable thing to check over here? Or how about negative 100? Right? Or negative 1,000, or negative 1,000,000, right? All of those are in this interval. And remember, our goal isn't to find the exact number. Our goal is to think positive or negative. And we want to pick a value that makes that very obvious without us having to do a whole lot of work. So like negative 100. Are we okay that 5 times negative 100 is a really big negative number? And minus 3 is still negative? Do I care exactly what the number is? No, I just care that, oh, that's negative. And the same thing happens over here. Like 4 times negative 100, that's negative big number. Plus 7, still negative, isn't it? Negative is negative is positive. Is positive bigger than 0?
Mm-hmm.
Okay, so that one works. Now we pick a value in here.
Can you still pick 0?
Yeah, anytime you can pick 0, you want to pick 0. So we pick 0, and then I think, well, 0 minus 3, that's negative. 0 plus 7, that's positive. Negative plus positive, negative. Not bigger than 0, so this doesn't work. Then I pick a number over here, positive.
Wait, if it was 2 negatives and then that's a positive, the positive isn't less than 0, right?
It's supposed
Oh,
to be
it's greater than.
Yeah, it's supposed to be great.
All right.
Yeah. And then I pick a value over here, pick positive 100, and so that's going to be really positive, that's really positive, all right? Positive number is bigger than 0, that works. And so now when I write my answer, this interval and this interval, when I write my answer in interval notation, this interval is going to go from negative 100 to negative 7/4. I include this because it's filled in, but infinities always get a parentheses. This, I'm going to go from 3/5 to infinity. I get to include this because that's filled in, and infinities always get parentheses. And then I got to put the union thing in between. Right?
I have a question.
Yes.
If numbers below negative 7/4 were included and then the middle part isn't included, is it possible that numbers coming after 3/5 are also not included?
Well, what we've just done is, so the number line has all the possible answers, right? And what we're trying to do in this checking process is to check which groups of numbers work. So, like when we tested this, all right, we tested one number that worked, that meant this whole group worked. We tested this interval, and one number didn't work, which meant this whole interval didn't work. And when we tested this interval, we found out one number that worked, which meant the whole interval worked. So, I'm not quite sure. Just because this doesn't work doesn't mean, I'm trying to show that this does work. Because what we're doing is testing intervals to see which interval works.
Right, but if, like, is it mathematically possible that if you have those 2 points in an equation, that, like...
Is it possible to have both of these work or both of these not work with a different equation or different inequality?
Yeah, is it possible to have both of those sections not work when there's 2 points?
Yes, but that requires a more complicated thing up here.
Oh, okay.
Okay.
So
Which-
we won't be...
Not now, but the next chapter.
Oh, okay.
Okay. All right. So, of course, I'm not going to give you questions that look like this, right? My main goal is, what if I gave you a question that looked like x squared plus 10x is less than or equal to negative 16. So write that down. And our job is to solve this. All right, how do we,
We were writing that one down.
this one, yeah. So our job is to solve that. Well, what often happens in math is you learn how to do something. Like, we know how to solve something that looks like this, right? This is easy, right? And then if I give you something and I give you something else, your job is, well, can I make this look like this? Right? And the way you approach solving inequalities is pretty much it's exactly the same way you solve, where you're solving equations. Anytime you see x squared and x in a number, what do? Like, had I given you this problem, had I given you x squared plus 10x equals negative 16, and I said solve this, what would you do?
Remove the 16 over.
What?
Remove the 16 over.
Set it equal to 0 and factor, right? Anytime you see x squared, or actually x to any power other than 1, if you see x to any power and stuff, the only way you can really solve this is set it equal to 0 and hope it factors. Actually, that's not the only way, but that's what happens about 95% of the time. Anytime you see x squared and x in a number, you go, okay, I'm going to set it equal to 0 and factor. Well, if you see that with an inequality, guess what you do?
Do the same thing.
Do the same thing, right? Get a 0 over here and see if it factors. All right, so let's get a 0, right? So that's going to give me x squared plus 10x plus 16 is less than or equal to 0. Now, let's see if this factors. All right? So I go through and it's like, okay, how does this factor? Well, let's see, an x and an x, 16, 4 and 4, not going to give me the 10, but I bet 8 and 2 does. So plus 8 and a plus 2. And so now, what are my boundary points?
Wait, how would that give you 10?
Yeah, 8x plus 2x gives me 10x.
Oh, -8 and -2.
So my boundary points are -8 and -2. So I'm going to put those on my number line. I just have to make sure I put them in order, right? You got to make sure things are in order. You don't put the 2 here and the -2 and the -8 here, because that would be bad. Put my circles in. There's a line. They're equal to, so that means I get to fill them in. And now I have to go about testing. So how do we test? Pick a value over here. Negative big number. Negative big number plus 8, that's going to be negative. Negative big number plus 2, that's going to be negative. Negative times negative is positive. Is a positive number less than 0? No. What do I pick here? Hint, not 0, right?
-6.
Yeah. Everybody okay? We can't pick 0. I just want to make sure you don't always get to pick 0 for the middle, all right? So -6 plus 8, that's positive. -6 plus 2, that's negative. Positive times negative is negative. Is negative less than 0? Yes, it is. And then I pick a value over here. Big 0. Or you can pick a big number, but 0 works, right? 0 plus 8 is positive. 0 minus 2 is...
Would you be able to pick positive 100 for that?
Yeah. You can pick any number in this interval. And if you pick 0, you get positive is positive is positive,
What
right?
if you picked -1 with that?
Yeah, you could. But you get the same...
Yeah.
You're going to get the same answer. What I'm trying to do is get you to pick values that make your job easier.
Yeah.
I mean, to be honest, you could pick 2/3. I really wouldn't want to, right? What you want to do is, since you get to pick any value you want to, pick a value that makes your job easy. And so this doesn't work, and so it turns out the only thing that does work is this interval from here to here. So I go from -8 to -2, and I get to include them. Does that make sense? Okay. All right. So there are some tricky answers. There are some tricky problems related to this. If I've got time at the end of class, I will talk about them. But right now, I want to revisit graphing. So let's say I give you y is equal to 2x minus 3 squared plus 1. And I want to graph this. Okay. So, well, the most important part in graphing a parabola is what? Find the vertex, right? All right. What's your vertex?
Is it 3, 1?
3, 1. All right, it's in vertex form, right? Yeah. So I end up with 3, 1. Okay, so I'm at 3, 1. I get a dot. We know this is a parabola turning up. We got to plot a couple extra points. You know, here's my lovely little XY chart. And how you pick your points, if your vertex is 3, pick X values that are right around it. So I'm going to pick 4 and 2. And to save us a little bit of time, if I plug in 2, I'm going to get 3. And 4, I'm also going to get 3. So here's here, here's here. There's my dots. And now I can sort of graph my parabola. Yay, right? Just a review of here's how we graph a parabola. Oh, this isn't the problem I wanted to do. See, we're not talking about just quadratics. We're talking about quadratic inequalities, right? And since we're talking about quadratic inequalities, I'm not interested in y equaling this. I'm interested in y being greater than or equal to. And so what does that mean, right? Well, you know, what does that mean as far as my picture goes? Well, remember when we graphed inequalities with lines? Like we draw a line and we shade up or down? Okay? Well, the same thing's going to happen. But the way I want you to look at this parabola, do you see how this parabola, if I'm just looking at the parabola on the graph, I've got inside the parabola and have outside the parabola? And so you're going to shade either inside the parabola or outside the parabola. How do you know? Well, this says y is bigger, right? So if y is bigger, that means we're going to shade up. And if I'm shading up, does that imply that I'm shading inside the parabola or outside the parabola? Inside. Okay, good. Done. So what's the difference between graphing an inequality with just without a quadratic inequality as opposed to graphing just a regular parabola? You shade, right? And the trick is you just got to know if it says shade up, all right, we shade up until we get this part. All right? Look at another version. What if I gave you y is greater than, let's do negative 3x plus 1 squared minus 2. So I'm interested in what that picture looks like. Well, I guess I have to erase this. And, well, same thing, right? First, most important part is, well, where's my vertex? So where's my vertex?
-1, -2.
-1, -2. Okay, that's not bad. -1, -2. Which way is this parabola going?
Down.
It's going down, all right? I'll do a little, if I were going to plot some points, -1 is one x value that I'm interested in. I'll plug 0 and I'll plug -2 in. Again, to save us some time, because I kind of want to finish this, it's going to be here and here. Okay? Now, there is a little difference of, do you remember when we graphed a line, if it was like greater than or equal to, we had a solid line? What did we do if it didn't have the equal to sign?
Dash.
Dash. So guess what I'm going to do here?
Dash it.
I'm going to draw a dashed parabola. Okay. Now, again, I have this dashed parabola, and I'm interested in, I'm either going to shade inside the parabola or outside the parabola. How do I know? Well, it says y bigger. Am I shading up or shading down? I'm shading up. So if I'm shading up, does that imply I'm shading inside or outside the parabola? Outside. See, because in this case, up was outside. In the previous example, up happened to be inside. But in this case, up is outside, so that means I'm shading everywhere that's outside. Does that part make sense?
Would you shade above?
Oh, yeah. It's everywhere except that part.
So if it was included and then we had to do a dash and it was still going down, would we also shade?
Yeah, if this had been an equal to, the only thing that would have changed is you would have drawn a solid line here. The
Oh, you
shading would have
wouldn't
been
shade
exactly the
inside.
same. Yeah.
And so wait, what's the reason why we shade everything except for the inside again?
What?
Yeah.
What's the reason why you shade the outside again?
Well, because it says y bigger, right?
Yeah.
So that means above whatever line you drew. And if you think, put a dot, put your pencil on whatever you draw. If you go up, do you see how that's the outside part? With a line, it cuts. You can almost think that like a line cuts it in half, and so you think this half or the top half or the bottom half. With a parabola, it's not really a line. You got this curve. So I want you to think up or down, and sometimes it's inside, sometimes it's outside. All right. Well, what about? Oh, whoops. Should have. What if I give you y is less than 2x squared minus 12x plus 19? I asked you to graph that. Well, can we agree that's a parabola? Is everybody okay with that? Can we agree it's a parabola turning up? Because it's x squared, we know it's a parabola turning up, okay, there's positive, right? So I have to graph it. So how do I go about graphing it? What do you need to find first?
The next one.
The vertex.
Oh.
Yeah. Right? Isn't that what anytime you're graphing a parabola, what we have to find is the vertex? So if I want to find my vertex, right? My vertex has an x part, my vertex has a y part. So to find our x part, right? what was that thing? That negative b over 2a. So negative b over 2a is going to be the opposite of that, which is 12 over 2 times 2. So it'll give me 12 over 4, which gives me 3. If I know what the x part is, how do I figure out the y part? Plug it back in, and so it's going to give me 3 squared is 9 times 2 is 18 minus 36 plus 19. Let's see, that's minus 18 plus 1 gives me a 1. And so here's what I know. I've got my vertex at 3, 1. I know it's turning up. I do need to plot a couple extra points, but I'm going to go ahead and kill the suspense. This is actually the same problem that we did. This is the same one, the first one we graphed. If you look back at the first one we graphed, it had a vertex at 3, 1, but I just gave it to you in vertex form. This is the same thing in standard form. If you go through and you do your little XY chart, and we know what happens at 3, plug in 2, and plug in 4, what you're going to find out is those values are here. It's less than, so I have to draw a dash line. Am I shading up or down?
Down, outside.
I'm shading down, and so in this case, everything's outside. Does that make sense? Now, I want to connect the two ideas. So idea number 1 today was just solving an inequality, right? Now number 2 was graphing an inequality. How are those related? So how those are related, I want to go back to this. Let's say I talk about y is greater than or equal to x minus 2, x plus 4. Right. And what I'm going to do is graph y equals. So if I graph this, this has a y-intercept at negative 4 and at 2, right? It has, let's see, it's got a vertex at, let's see if I plug in negative 1, negative 9, which is like way down here, and 8. This is a rough picture of it here. I'm not requiring you to do this. I'm just trying to connect things. But if I gave you y equals, right, this would be our picture. And are we okay that y is bigger than that is this part? Actually, let me pause this. I want to make sure I haven't.